everyone. I am Nahiyan Habib, and today my friend Sirat and I are going to be demonstrating how our computer programming Python project works. Now, the name of our program is Moodify, and I will be demonstrating the objectives of our project while Sirat is going to show you how the code works. And after that, I will go through our self-evaluation checklist. So, to give you a short background of why we are doing this project, basically, as human beings, we go through many different highs and lows in our lives. We feel many different types of emotions. And lining every single one of these emotions are the songs we listen to when we feel certain feelings. Now, let's say this is you, and you have a Spotify playlist which has many different songs in it. Let's say you want to specifically filter through the Spotify playlist to find songs for a specific mood, songs that fit a specific mood. That is what our program is going to help you with. So, let's take a look at the objectives of our project. Our main objective was creating a Python program that takes songs from your existing Spotify playlist, and basically, our program is going to group these songs into categories based on the song's moods. Now, these moods will be determined by the song's features. Um, Now, another objective of ours is applying everything that we have learned in our course, along with basically, we want to broaden our knowledge of Python libraries and APIs. Now, the libraries that we used in our project include Spotify, scikit-learn, pandas, JSON, requests, NumPy, warnings, OS, and time. So in total, we used 9 libraries. Now, the steps of our program. Let's take a look at this. Basically, one thing that I would like to state, first and foremost, the playlist that is going to be used by the user. This playlist has to be made public. Okay, now as for our steps, first of all, our program is going to retrieve all of your Spotify playlists from your account. Next, uh, basically your playlist contains many different songs, right? Now, our program is going to extract features from every single song. These features being valence, danceability, energy, and many other things. So these features are going to be extracted out, and then these features are going to be checked and matched. And after we do that, the songs are going to be clustered and grouped together. Next, these clusters and groups, these clusters that are similar in nature, they're going to be assigned a specific mood label. Now, my friend Sirat, he is going to demonstrate the code of our app. He's going to show you how the code works. So let's take a look at that.
And I'm Sirat, and I'm going to show you a demo of our program Moodify. So welcome to my Windows PowerShell. Um, so let's just run the program. So the program is run with we will want to run the main.py program, right? And it will give us the welcome screen. So welcome to Moodify. So as Archie already explained what this program does, so here we have a little splash screen, let's say, and we will have to press enter. So once we press enter, it will redirect you to your browser page to log into your Spotify. But since I am already logged in, it would just redirect me to my browser. So let's see what that does. So yeah, you saw that it logged into my browser, and I already have given permission to for Moodify to gain access to my Spotify data. So here are all my playlists that I have saved on my Spotify. Yeah, it's important to know that these playlists are all of the public. Oh, well, these playlists are all playlists that I have made public, and I have chosen to display it on my profile page on Spotify. So this is not all the playlists that I have, but these are the ones that are public on my Spotify page, the Spotify profile page. So we're gonna use playlist number one, this one, test data, because these are playlists that have chosen like many diverse songs just to test this program out. So we enter the playlist index, so I enter number one and press enter, right? So now it will ask us if we want to get genre tags too. So these genre tags will come from Music Brain's API, and this will take really long But for the sake of this demo, and I think for the sake of you guys too, you guys should also run the tags with the tags on. So let's enter Y, and now it will get all of our data and all of our tags. So we now have just to wait a little bit. So 4 songs are not found in the record beats database. That's okay. That's very normal, actually. And as we can see here, is the program is telling us that it's searching make data, music brains for 48 songs, and this will take around 48 seconds due to rate limiting. Yeah, we just have to wait. So we will cut to when all the songs are found. Now we are done compiling all our results, and we have a little summary here. All the 48 songs that have been processed. So this playlist has 52 songs, only 48 were processed. Okay, that's not a big deal. And only 18 of which have tags, right? So now, yeah, so we see all the audio features that it compares. So these are all the 7 audio features. And it has 4 clusters, and these are like clustering scores. So these scores are not like that great, but compared to other playlists, maybe I think this is a very, very good score, right? So let's look at this cluster just for as an example. So we have all our average audio features. So we just can infer, like based on human, as a human, we can see that the main like thing here is that they have low instrumentalness and very low speechiness. So what does that mean? So instrumentalness is about how much instruments is in this song. Like like an orchestra would have a high instrumentalness, while maybe a song with just a beat and a rap over it will have a low instrumentalness. However, speechiness refers to how speechy the song is. So a song that has a lot of like talking, a lot of like rapping, for example, will have a high speechiness, but a song with singing or no vocals at all will have a very low speechiness. So these songs have a low speechiness. So we can maybe think that these can be some songs might be a bit instrumental or not, and let's look at what's up. So the sample songs here are so these are like basically jazz songs and folk songs are put into this group, and it's curious because these songs all have a very like relaxed vibe, and we can have some of the adjectives here. Not every like metric is filled out, but we see here that mood is reflective, and I think that that is the best adjective to refer to these bunch of songs here. And we can look at another one. Here is the third cluster, where we only have 4 songs in this cluster, but we can see that these are all 4 of these songs are all instrumental songs, and many of these are all three of these are like classical music, and one of them, Alien Observer by Grouper, is an ambient song, say. And it fits in with this group of songs. And here are so many words to go along with it, and smooth, warm, light, great. They coincide so perfectly with these songs, which I think is awesome. So now it asks us, do you wish to save the data in a CSV file? And I'm going to say yes. So we this allows the user to be able to like keep hold of the data after the program has finished, right? Or we can even look at more insight if you wanted to. So we say yes, and here they're asking us for our file name. So we will enter test data. And now it has saved all this data to test data.csv. So let's open up test data.csv. So it's saved in the same file as your main.py file. And let's take a look at at the data that we have gathered. So here we can see in this spreadsheet that we will have all the audio features of every song as alongside the Spotify ID and the Record Beats ID. And in some clusters, we will even have if all the songs in the cluster are like of the same genre, it will give out the common tags as we as is hinted here. So let's try that out for the next yeah, let's just try that out. So I'm just gonna do the same thing. So we just skip to to that part, okay? It took a little while for the program to run because this is a much bigger playlist, but we can see here at the clustering of this playlist, we can see the common tags. So alternative rock, pop rock, right? For here, alternative rock and rock. So these are common tags that we can see. If we allow tags from music brains to run. All right, so let's just show you guys how much faster the program actually is without the tags. So let's just clear quickly. So I'm going to use the same file, same playlist, test data to just show you guys, compare. So let's just write in one, and let's say no. So we just run, and it can be whatever. It doesn't really matter, just as long as you don't write a Y. So okay, so same old stuff, but now we are not. It doesn't tell us how long we have to wait for the sound to get the tags. Oh man, already it's done. It's already done. Okay, that's awesome. So yeah, that's basically concludes the demonstration of this program, Moodify. So back to Archie.
Now that Sirat demonstrated how the code works to you, I am going to be doing our self-evaluation. Now, for project completeness, we basically used 9 different libraries. Now, the essence of this Python project was to learn how to use libraries beyond what we learned in class. So we properly implemented what was asked. After that, um, the requirement was to do more than 100 lines of code. Um, in our program, we used 800 plus lines of code, and the requirement was to also use about 5 different functions to ensure that the code is stable and structured properly. We used about 20 different functions for our program. Moving on, we used many different programming concepts, and the core requirements, the core programming concepts that were required to be used include if and else, lists, loops, tuples, and dictionaries. All of these were implemented in our code, as you already saw. Next, let's take a look at the difficulty level of our project. So we faced a few different difficulties while making the project. The first one being API feature deprecation. So basically, the primary Spotify web API that we were initially planning on only using, this removed crucial audio feature data, meaning features such as energy, valence, danceability. These were removed. So that's why this essentially degraded our core data set that we were supposed to use for the project. So this is why we had to rely on secondary APIs such as Reco Beats and Music Brains. And these introduced 2 different issues, these being inconsistent data quality and accuracy. We couldn't really receive the proper data that we needed. And along with that, these also included a limited data scale compared to the original source that was Spotify Web API. Along with that, another difficulty that we faced was using machine learning because it's something entirely new to us. We used k-means clustering, and that required extensive attention and effort. We had to learn something entirely new. So, all in all, I'd say that this project was quite difficult because we had to face many challenges while trying to build the code. So, yeah, we persevered through all of that. Moving on, as for code quality, basically, as you already saw, as Sirat already demonstrated, each task is organized in a task specific file. Basically, if you check, we have a file for feature extraction, which extracts out your features, then features from the songs. Then we have the music descriptor file, and the playlist selection file. So as everything is neatly organized, our code quality is really useful. Along with that, we basically used a very clear structure with absolutely no redundancy. The fact that we use functions, about 20 functions, this ensured that our code had a very clear structure with absolutely no redundancy because no code had to be repeated. Along with that, our code is easy to read for other programmers. Now, we used useful comments in many lines of code, and along with that, our code essentially works really well. And with that, I would like to end this presentation. Thank you so much from my friend Sierra Danai.